Tonight, we step into a realm that feels impossible, a place where the earth has quietly built cathedrals of crystal in total darkness. This is the story of the Cave of Crystals, a mineral world so extreme it blurs the line between science and myth. The underground cathedral, a world made of crystal. Imagine breaking through a rock wall deep underground and stepping into a chamber where every direction gleams. The floor is not stone, it is crystal. The walls are not rough, they are smooth, glass-like planes. Enormous selenite blades, some longer than city buses, crisscross the space like frozen beams of light. Your headlamp fractures into 1,000 reflections, and suddenly the cave feels alive, shimmering, watching. This is not a dream. This is a real place, buried beneath the desert of northern Mexico, hidden for hundreds of thousands of years. Inside this cavern, the earth has grown some of the largest natural crystals ever discovered. Transparent, towering structures weighing tens of tons, formed entirely by heat, water, and patience. The question is not what this place is. The question is how something like this is even possible. Giant mineral worlds, when geology goes extreme. Crystals are everywhere on Earth, in sand grains, in salt, in gemstones, but they are usually small, limited by chaotic environments. The Cave of Crystals is different because it represents a perfect storm of geological conditions, one so rare that it exists in only a handful of places on the planet. To understand this cave, we must first understand crystal growth itself, not as decoration, but as a physical process governed by chemistry and time. The engine below: heat, magma, and hydrothermal systems. Deep beneath the cave lies heat, residual energy from magma intrusions that warmed the surrounding rock long after volcanic activity subsided. This heat did not melt the cave. Instead, it created a hydrothermal system. In such systems, groundwater circulates through hot rock, dissolving minerals as it moves. The hotter the water, the more material it can carry. In the case of the Cave of Crystals, the water became saturated with calcium and sulfate ions, the raw ingredients of gypsum. This mineral-rich water seeped upward into natural underground cavities, spaces left behind by faulting and mineral dissolution. And crucially, these chambers were sealed, isolated from turbulent flow, vibrations, and sudden chemical changes. That isolation changed everything. The golden rule of giant crystals: stability over time. Crystals grow through two stages: nucleation, the formation of tiny seed crystals; growth, the gradual layering of atoms onto those seeds. In most environments, nucleation happens constantly. Many seeds form, and the available material is split between them, producing millions of small crystals. But in the Cave of Crystals, nucleation was suppressed. The water was chemically pure, extremely stable, barely supersaturated, undisturbed for geological timescales. This meant very few crystal seeds formed, and those that did had no competition. Every dissolved ion in the water had only one destination: onto the surface of existing crystals. This is how giants are born. Selenite, the perfect mineral for monumental growth. The crystals in the cave are made of selenite, a transparent form of gypsum. Unlike harder minerals such as quartz, gypsum has a unique solubility curve. It dissolves easily in warm water and precipitates slowly as temperatures shift. As the hydrothermal system cooled imperceptibly over tens of thousands of years, gypsum began to crystallize, not explosively, but patiently. Growth rates are estimated at fractions of a millimeter per year. That may sound insignificant until you multiply it by hundreds of thousands of years. Time did the rest. Crystal geometry: why they grew so long. Crystals grow according to space and ion flow. In the Cave of Crystals, the cavities were elongated, allowing crystals to extend outward without obstruction. Ion-rich water flowed gently along preferred directions, feeding crystal faces unevenly. As a result, crystals stretched into long prismatic blades, sometimes exceeding 12 meters in length. Their astonishing clarity reveals another clue: purity. These crystals grew in water nearly free of contaminant, few inclusions, minimal defects. The result is mineral architecture so clear that light travels through it like glass. Time capsules inside stone, fluid inclusions. Trapped within some crystals are microscopic droplets of ancient water, sealed inside as the crystal grew. These fluid inclusions are priceless scientific records. By heating and analyzing them, scientists can reconstruct temperature, salinity, chemical composition, growth conditions. Each droplet is a frozen moment in geological time, a preserved whisper from the cave's formation era. Some inclusions even raise a startling possibility. The same hydrothermal conditions that allowed the crystals to grow created one of the most extreme environments ever encountered underground. Inside the chamber, temperatures soar between 45 degrees Celsius and 60 degrees Celsius. Humidity approaches 100%. Air movement is minimal. Evaporative cooling is impossible. In these conditions, the human body cannot regulate heat. Sweat does not evaporate. Core temperature rises uncontrollably. Heat stroke can occur in under 10 minutes. Even trained personnel wearing protective gear operate under strict time limits, often no more than 15 to 20 minutes inside the chamber. Without cooling suits, survival time drops to minutes. This is not a cave you explore, it is a cave you endure. Beneath our cities, beneath deserts and mountains, the Earth is still building hidden worlds, crystal cathedrals, molten chambers, and ecosystems that operate beyond human senses. The Cave of Crystals is proof that the planet does not need life to create wonder. It needs only time, and time is something the Earth has in abundance. If you want to keep uncovering the planet's most secret architectures, from crystal worlds beneath our feet to alien oceans beyond our sky, subscribe to Discovering the Unknown, because the strangest places in the universe are often hiding right below us.